This lecture is on radioactivity. Radioactivity is a very interesting topic in physics, and I would like you to concentrate, because there are some aspects of this topic that are a little bit technical. So let's get started. What then is radioactivity? As you can see, radioactivity is the spontaneous emission of radiation from a radioactive element or substance like uranium, polonium, etc. So it means that uranium, polonium are examples of radioactive element, and they can emit radiation spontaneously. Radioactivity is concerned with special changes taking place in the nucleus of an atom. So in other words, in radioactivity, we'll be talking about special changes that are taking place in the nucleus of an atom. So if you look at it, radioactivity is concerned with special changes taking place in the nucleus of an atom. Unlike chemical reactions, which involve the electrons of atoms. So here we're looking at a comparison between chemical reactions and radioactivity. In chemical reactions, we are only concerned with electrons, and electrons are not found in the nucleus of an atom, they orbit the nucleus. However, in radioactivity, we are interested in the particles that are present in the nucleus, and that's why we said radioactivity involves special changes taking place in the nucleus of an atom. Radioactivity is not affected by external factors like temperature and pressure. External factors like temperature and pressure do not affect radioactivity. Now, during radioactivity, an enormous amount of energy is released. That is, huge amount of energy accompanies radioactivity. Now this will take us to types of radioactivity. If we back up a bit, just to read what we wrote there, during radioactivity, enormous amount of heat is involved. Types of radioactivity now. We have two types of radioactivity. Number one, we have natural radioactivity. Number two, we have artificial radioactivity. Artificial radioactivity is also known as artificial transmutation. So that's another word for artificial radioactivity. Now, the natural radioactivity is what we are discussing. That is, you have a radioactive element that freely emits radiation without being forced. It does it spontaneously, and that's why it is called natural radioactivity. For artificial radioactivity, it is forced. That is, the nucleus of the atom of that particular element is bombarded with particles, and these particles force the nucleus to behave like the nucleus of a radioactive element. Now, what are the types of radiation we should be looking at? Number one, we have what we call the alpha particles. and then we can write it as this. Second one, which is number 2, beta particles. We can write it like this, and the last one is gamma rays, and then we can write it like this. This will take us to properties of alpha particles. What are the properties of alpha particles? Alpha particles are helium nucleus. What do you see? And you see the emission, the radiation is alpha particle. When you see a helium nucleus, we say that radiation is an alpha particle. This process here is referred to as disintegration or decay. So it means that the process of emission of radiation by a radioactive substance is called disintegration, or what we call decay. So in other words, this radioactive element, when it decays and produces an alpha particle, you will see the helium nucleus, and then you will see the daughter element, the new element that is formed as a result of such disintegration. So then you have the radioactive element which decays, which disintegrates, which breaks down, which emits radiation, and in the process of emitting radiation, it produces a new element called the daughter element, and the type of radiation is determined by what is represented. So if you see He42, it shows that it's an alpha particle. In other words, we use helium nucleus to describe alpha particle. Now, the A there, you are familiar with that. You must have been taught that in your previous class. A there is the mass number, or what we call nucleon number. The Z is the atomic number, or what we call the proton number. So mass number or nucleon number is the number of protons and neutrons in the nucleus of an atom, or in the nucleus of the atom of an element. It is usually represented with the letter A. So if we want to represent our mass number, we use A to represent the mass number. We use A to represent the mass number. We then move on to atomic number, or what we call proton number. Atomic number or proton number. Atomic number is the number of protons in the nucleus of the atom of an element. It is usually represented with the letter Z. So then, if we back up a bit, A there is the nucleon number, Z is the proton number. So if we have a radioactive element, uranium 23892, 238 is the mass number, the one we call nucleon number, and 92 is the proton number, otherwise known as atomic number. Now, don't forget we said atomic number is the number of proton in the nucleus of an atom. So it means that 92 is actually the number of protons. If we want to get the number of neutrons in the nucleus, we will just subtract 92 from 238 to get 146, since we said that the mass number or nucleon number is the number of protons and neutrons in the nucleus of an atom. Don't forget, we're looking at the properties of alpha particle. The properties of alpha particle. We'll continue this in part 2.